So for exercise 3C, you need to know how to use our divisibility test in order to determine whether or not you have a remainder being left. So for example, if you're trying to divide a number by 1, we just know that all numbers are being divisible by 1, so you're not going to get any remainder. So for all numbers, you should be able to divide by 1. For 2, you need to make sure that the number that you have, it's an even number. So remember that even numbers must end with a 0, 2, 4, 6, or 8 in order to be divisible by 2. For part 3, the number 3, you just have to check if the sum of the digits, if you add them all together, can you divide it by 3 without getting any remainder left? For 4, you just have to look at the last 2 digits and you must check if it's divisible by 4. So it doesn't matter how long your number is, you just look at the last 2 numbers and see, can you divide it by 4? 5. The last digit must be a 0 or a 5. For example, it can be 10, 15, could even be a number like 55, or even like 105, as these numbers end at a 0 or a 5. Now for 6, you just have to check if it passes the tests for 2 and 3. So it has to be even, and when you add all the digits together, it must be divisible by 3. Don't worry about 7. We're not worrying about this because it's quite a difficult test to recall. 8, basically for 8, you look at the last 3 numbers and then you check if it's divisible by 8. And for 9, it's similar to 3, so you just add all your numbers together and can you divide it by 9? For 10, you must check that the last number is a 0, and I'll go through a few examples. So this is question 1 from 3C. Determine whether or not the following calculations are possible without leaving a remainder. So I've got 21,735 being divided by 3. So I need to look at my test for 3, which is over here, and it says that the sum of the digits must be divisible by 3. The sum of the digits means that you're just adding all your numbers together. So I've got 21,735. So I'll do 2 plus 1 plus 7 plus 3 plus 5. So I'm adding all my numbers together. So 2 plus 1 is 3. 3 plus 7 is 10. 10 plus 3 is 13. 13 plus 5. This equals to 18. Now using my value of 18, I need to check, can I divide it by 3? For 18, I know that 18 divided by 3 is equal to 6, and there's no remainder. So the answer for 1A is yes. This number can be divided by 3, and I won't get any remainder. So I'm just using this test to determine, can it divide it by 3 or not, without actually doing the calculation. Let's try 1B. Can this number 46,028 be divided by 4? So for 4, it says the number formed from the last 2 digits must be divisible by 4. So I'm going to ignore 460. I'm just going to look at the 28 here. So I have 28 and I divide it by 4 and I would get 7. So this also would be yes. If I had this number being divided by 4, I'm not going to get any remainder. Let's try C. I'm being divided by 8. So for 8, which is this one, the number formed from the last 3 digits must be divisible by 8. So currently I have 300,000 and 100. The last 3 digits is 100, 100. So I am going to be doing 100 divided by 8. So I set up my division equation. So I've got an 8 here, 100. So let's do this. All right, 1 divided by 8 doesn't work, so I need to carry the 1 across to the 0. So this is 10. 10 divided by 8 is 1, with a remainder of 2. So this is 20. 20 divided by 8 is 2, and I have a remainder of 4. Oops. So because I have a remainder here of 4, the answer is going to be no. This number is not divisible by 8. I'm going to get a remainder if I do that calculation. So that's the first 3 questions for 3C using your divisibility test. So as you're going through the questions in this exercise, I highly recommend you have a look at the table that you've been given and try to recall all of these tests for divisibility. Good luck.